we're going to practice thinking about functions besides z equal to f of xy, in this example, using a cylinder. So we're going to try to find the surface area of the sides of a cylinder x squared plus y squared equal to 4 for z between 0 and 3. And so that's a cylinder with height 3 and radius 2. Sorry, height 3, radius 2. And we're going to sketch it, so don't worry. So here's our x, y, and z. Here's the circle shape that forms the main part of the cylinder. And so what we're imagining is this cylinder goes up to height z equal 3, starts at the xy plane, 0, and the radius of the cylinder is 2. And we want to find the surface area on the outside of the cylinder. Kind of like if this cylinder was a can, we want to know the surface area of just like the like label that you wrap around the side of the can. We don't care about the top and bottom. And I know that you could go ahead and calculate that yourself. You would find the circumference of the circle, you would multiply it by the height of the cylinder, and you would get your answer. But we're going to do this a more complicated way to practice new skills. So how are we going to find the surface area? If I just gave you this problem after everything we did up to this point, you would say, okay, I know that my surface is this, but I can't solve for z, so I can't take derivatives. What am I supposed to do? So we need to reorient the problem. Instead of finding over the region R, root 1 plus fx squared plus fy squared dA, we have to change so that we're thinking about something that depends on x and z or y and z, and that will help us out a bit more. So let's go ahead and do, which order does your book do? Okay, I don't know what your book does, but we're going to do XC. So thinking about this instead, where here's our X and here's our Z, and up this way is Y. Let's just think about the half of the cylinder that sits in the positive half of this coordinate system. So what we've got is kind of like this. So I've got kind of this shape where I cut my cylinder in half. I ignored negative y values, so I cut off like right here. And I've just sketched for you the side of it, basically. Maybe a bit better. Not very well, but here's a can on its side that I've cut in half. And so when we look at this way, we had the curve x squared plus y squared equals 4. And I'm writing y in terms of x and z now. So y is the square root of 4 minus x squared. The positive or negative, but I chose to think about the positive part first. So that's kind of like my f of, oh wait, I changed letters for you all. That's my h of xc. So my h sub x is harder than my h sub z, which is 0. So there's no actual z in this equation. No matter how far I go along the z-axis, the shape of my cylinder doesn't change. It's just from positive to negative x, I get that semicircle shape. So my derivative of 4 minus x squared to the 1/2 is 1/2 4 minus x squared to the minus 1/2 times minus 2x. So that's minus x over root 4 minus x squared. That's my h sub x. And instead of putting it there where I know I'm going to have a lot of algebra, I'm going to go ahead and start on a new page. So now I've got my 1 plus h sub x plus h sub z, both squared dA. And I can go ahead and plug in what I found. I found x is minus, oh, the 2 canceled out, minus x over root 4 minus x squared plus 0 squared. I just want to check I did that right. Minus x over root 4 minus x squared. Okay. And let's simplify that real quick. So 1 plus x squared over 4 minus x squared plus 0. So that's going to become okay, 4 minus x squared over 4 minus x squared plus x squared over 4 minus x squared. Okay, good. My x's are going to cancel out. That would not have been pleasant. Okay. So when I take 4 minus x squared plus x squared, I just get 4 over 4 minus x squared. So I'm going to go ahead and even write this as 2 over root 4 minus x squared. Just make it extra clear that I really only have to think about a square root in the denominator. Okay, so all that was finding this thing that we usually called square root 1 plus fx squared plus fy squared. But I changed my perspective so that my y was a function of x and z. So I found my hx squared plus hz squared plus 1, and I just had a whole lot of simplification to do. The other part of this, the other part of this that we have to take care of is finding the region R. And so the region R is our projection down into the xz plane. So it's this right here. If I put a light up where the positive y-axis is and I shine it down on this can that I cut in half, what's going to be in the shade? And it happens to be that the shade is, my z went from 0 to 3, and my x goes from positive 2 over here to negative 2 over here. That's just the edges of the circle, right? But the shape is actually a rectangle, kind of like a slice through a can is a rectangle shape. It's just that those slices get thinner and thinner in this kind of circular way so that, here you've got a skinny rectangle, here you've got a thick rectangle. So all that to say, our region in the XZ plane is a rectangle, and I'll go ahead and sketch it for us. So here's x, here's z. It goes from 0 to 3 and from minus 2 to 2. So it's like this. And you can imagine that the can is kind of sitting above it like that. So 0 less than or equal to z less than or equal to 3, and negative 2 less than or equal to x less than or equal to 2. So my surface area is the integral from 0 to 3, negative 2 to 2 of 2 over root 4 minus x squared dx dz. X went from minus 2 to 2, z went from 0 to 3. 2 over root 4 minus x squared. Okay, and so we can go ahead and evaluate this integral. I would have to remember a trig rule here to take my first integral with respect to x. It's going to be an inverse sine of x over 2. I think. Yeah, let's go with it. Inverse sine of x over 2, where x goes from -2 to 2. So when we plug in our bounds of integration, we're just going to get inverse sine of 2 over 2 is 1 minus inverse sine of negative 2 over 2 is negative 1. And then we know that sine is positive 1 at pi over 2 and negative 1 at negative pi over 2. Just from like your unit circle. So you could go ahead even and say this is pi over 2 minus pi over 2, so plus pi over 2. So that's just going to give us a whole pi. Oh shoot, I think I lost my 2 up front here. Sorry. There was a 2. Just this thing in the numerator. So this should give us a 2 pi out front, and then we're evaluating from 0 to 3 dz. So that becomes 2 pi. The integral with respect to z of 1 is just z evaluated from 0 to 3. So that's going to be 2 pi times 3 minus 0 is just 3. Okay, so we just got 6 pi for our answer, but I started this whole process by cutting my cylinder in half. And the reason for that is because we don't know how to deal with the surface that dips through the plane we're thinking about. So I cut it in half so it didn't dip below the XZ plane. But if I found the surface area of half a cylinder, I just have to double it to get the full cylinder. So the full surface area is 12 pi because 6 pi was for half the cylinder. And if at the start of this problem you had said, okay, so the circumference is 2 pi r, so that's 2 times pi times 2 is 4 pi, and the height is 3, so 4 times 3 is 12 pi as the surface area, you would have been done with this in like 30 seconds. But this was really good practice of switching how we think about problems, and then this non-intuitive thing that a slice of a cylinder is a rectangle.